Yes, so as was introduced, my name is Rene Rubalcava. I'm an engineer at a company called Esri, which is a mapping company. Uh, I've done these half stacks before, and they mostly have to do with mapping. That's kind of what I do. And also audio in some way, because before I went to school for geography, I was a music major for a while. Very brief, but I needed a job, so I needed to do something. Um, so this is called Map Along a Beat Path, right? And basically the idea here being that I like to talk about when you're working with maps that everyone uses maps in some way, right? They're on your phones, they're in your cars, multiple devices. Everything knows your location, even your TV, right? Knows your location and stuff. So you're using maps in a lot of different ways and location data in a lot of different ways. And they can do so much more than just, give you directions from here to a coffee shop. They provide a lot of different meanings. So a lot of times when I talk to people about maps and what do maps do, why are they so important? Maps are just another way to visualize your data. Everything you can put into a chart can probably be put onto a map. And they work really good together as well. There's a lot of like dashboards that have maps and charts together, right? And someone's gonna give me a timer, right? So I don't forget what I'm doing. All right, so they're all data driven, and maps are a really great way to tell a story. Now, one of the things that I've tried to do in the past is look at how you can use audio and music to tell a story. Am I like, okay, sorry. Okay, how you can use audio, music, and maps together to tell a story. So one way I've done that before is like looking at earthquake data. You look at historical earthquake data, and I've been able to show kind of like as the magnitude of the earthquakes go up over time, the beats might get louder or faster or more distorted or something like that. And all of this using something like the Web Audio API, which we've talked about a few times already before. It's a really, really fun API that you can play with, and you can really get low level with it. There's some other libraries out there you can use if you're not comfortable working directly with it to abstract things a bit, like Tone.js. P5 is a really great one too. It does a lot of other really cool things. They're fun libraries, but I really suggest if you want to get into it, just get down with the Web Audio API and learn kind of like how pieces work. So the idea here was that I wanted to take people's running data, right? If you have a watch, I think the Garmin's will do it, where if you go running, go for a hike or something like that, it'll track location and a timestamp based on a certain interval. And it also collects some other data, which is called extensions. And that could be like a heart rate, cadence. I think even some devices can collect temperature, right? So you get all this really cool data on your watches, and you can upload them to other websites to kind of view your trail on the map and share your runs with your friends and do all kinds of cool stuff. So my idea was, can you make a tune with your feet? Now, I don't go running, but I do work with a lot of people. Surprisingly enough, in the mapping industry, a lot of people like to be outside. So I got some really cool trails or runs from people from their watches that I can use for this demos. So the idea being that you could run, walk, as long as it can be mapped, we can use it for something here. Now, why would I bother doing this? A couple of ways, a couple of reasons is that there's this idea of accessibility also when you work with maps. Now, it used to be back in the day when you would put maps onto a page in the browser. The map would be made up of multiple image tiles. There would be like the graphics would be SVG graphics. And you can do accessibility. You could tab through them and do really cool things like that, right? So readers could understand things like that. Well, now everything is being done on canvas, right? You're drawing using WebGL, creating these maps. And if you work with canvas, there's not really a good way to do accessibility there. So this is kind of experiments into how that might work down the line. Now, I've talked to a few people at work about how that might get used at some point. Really don't know. It's difficult to tell how you could really use web audio to do some stuff like that. But the idea here I came with this one is called beat maps. And you're basically going to upload your run, and you can view it in the map. And then the stats of your run are going to be used to drive the music. So I put a little bit of code here, Python code behind the scenes, because I just wanted to show, I'm not going to go into the Python code and how everything works here, but basically Python's a great language to parse data. It's just a lot of fun to do it and really easy to do. These GPX files are XML, so you have to kind of get them. I need to convert them to something called GeoJSON, which is a very basic, simple kind of JSON format to serve location data. It's not exactly the best storage format, but it is a really good transportation format. So I take this XML, parse it, pull this extension data I was talking about that has heart rate and cadence and stuff, and turn it into this nice JSON file I can use. And I serve it using Flask, which is kind of the express for Python, if you want to compare it to Node or something like that. So let me go, sorry, talking to this. All right, let's go to the demo here. So I go ahead and choose a file, and I'm going to choose a very basic run to start with, just to kind of highlight some things, right? So upload it, and this one's not gonna, the map's not going to pan around this particular case, but just play it. It's a very basic melody. Now, one of the things you may not notice right away is the fact that the color, some of the colors change and whatnot. This is going at like a 1 minute pace every time it moves. So the cadence will be a darker color the faster they're going, or a lighter color when they slow down, right? Maybe within that 1 minute you slow down a little bit. And the heart rate goes up, so the dots get larger as the heart rate goes up, smaller as it goes down, right? This particular runner was going 78 to 189 heart rate on this small run. I believe this is around just some park somewhere. And I'll show some of the code here on this one. There we go. Okay, so basically we've got these components here that are going to show the map and everything like that. This is kind of stuff I work on. But then we come down here and we start looking at the audio stuff that happens here. So one of the things I do here is to visualize the data, I run some statistics on my GeoJSON file. So I want the average heart rate, the minimum heart rate, the maximum heart rate, the same for the cadence. And I can go ahead and I can just go ahead and query that particular data set, get the information back. And now I have all these values here I can do something with. And this is all pretty quick because these GeoJSON files aren't being streamed from a server. They're downloaded directly into the browser. So I can do all these really cool stat queries on them fast, which is key here because I want to use that to go and update these values for like the size and the color. So it does this little range. So the minimum range will be one color, the maximum range another color, and I can say the middle range will be a different color. Then it's going to make up all the other colors in between, which will come in important in another piece I'll show in a bit. And then the audio bits over here, I'm basically going to load my file. I have a melody. Now this isn't a beat being created just yet. It's just a melody I'm loading and playing at the same time you run. However, I do apply a little bit of a filter to it, which is kind of cool. And when we play with these filters, we're going to adjust when certain frequencies get cut off and whatnot based on some other values. We'll show that in a second here. Right here. So when I mentioned I don't center the map as I move around, I'll do that later. But I kind of want to show this one because what I do is I adjust the frequency based on the location of the first spot on the run on the page. So if it's to the left or the right, that's going to impact the frequency. So you get kind of a little bit of effect going on there. And I've got my melody, which we'll go and connect to that. See if we can notice it. Not sure. Refresh that. So you might hear a little bit difference on that one, but we start really playing around with it. Do this here. Okay, so what I'm doing here is I'm going to adjust the playback rate on the melody based on the Z value. Now this is kind of a flat surface. This probably isn't the best way to show the demo, but based on the elevation, it's going to adjust how fast this playback rate happens. All right. Okay, so you kind of hear that effect more. I have another demo that'll kind of like amplify that a bit more with a different trail run, but it's really kind of cool the way that works out. Let me undo everything I just did because I don't save everything. The next thing I can do is I can start throwing in some more effects, right? So I have my melody still, but I'm going to add a reverb in here as well. So reverb is kind of like an effect of like maybe I'm in a large room or a smaller room and I kind of want to adjust the audio for that. That's kind of where reverb comes into play here. And it's got a weird name in the web audio API. It's called a convolver, right? So that's like the technical name you would use for it. And I'm doing something else a little different here too. So instead of doing the playback rate based on the Z value, I'm going to do it based on the heart rate. And I have a little function here that's basically going to say that I want to set this tune value. It's going to be the pitch. So if you ever use like a keyboard or something like that to play music, and it's got that little pitch knob on the side, that's what this is going to do. I basically want to say that a heart rate of 50 is equal to negative 1200. A heart rate of 250 is equal to 1200. It's just these high and low ends you want to have. So that's going to be the high end of the pitch, low end of the pitch, right? So if I do it again, all right, so a little bit different. We're still messing with the frequency value here a little bit. And again, we're still just using a melody. The run itself is kind of driving what you do with the melody, kind of like you know, almost like a DJ, right? You have a record, you didn't write the music for it, you're just kind of scratching and playing around with some pitch and whatnot. That's kind of what we're doing at this point. But let's change it up a little bit. So now what I'm going to do is actually I'm going to load a few audio samples here. So I've got a kick, I have another kick that's kind of more of a bass kick, and I have a hi-hat. I'm also going to add in I added a pan node here, but at this point I decided I didn't want to, I wanted to keep the map center because some of these runs get really long and I kind of got tired of having a pan to follow it. And I didn't know where it was going sometimes. Again, I didn't do these. These are, someone gave me these. I'm also adding a delay, right? So kind of almost an echo effect of type and a distortion as well. And to be honest with you, the distortion is going to be based off of this little function here. This is some Copilot help here because I don't know how to write a distortion algorithm. So I just let Copilot help me out. Said I need a distortion algorithm. Great, here it is. I trust it works. I'm assuming it does. All right, so I give it a distortion curve of 400, and I start playing around with that down here some more as well. Now, I'm going to do this without applying that curve at first. And the distortion is going to change based on the heart rate that's happening. We're going to do a different run because I think they're more fun, some of these other runs here. So I think these larger ones here, like look, 3.8 megabytes. That's a good one. There's a 15 megabyte one too. That was big. Let me get a little closer. Okay, that's just kind of loud. That's kind of like dunk dunk loud, right? But that's with no effects. That's just the samples based on the heart rate, the cadence when they play. I do it every other tick, so it's not like everything playing at the same time, right? And we're going to go ahead and turn these filters on. And you can see here, I do it every other beat. I play one or the other, right? So it's not just chaos happening. There's some sort of order here. Okay, so that one's kind of, there's another one here that's actually plays a bit better, I think, to demo this. The cloud tram, this big one here. I can't turn down the audio, sorry. Okay, so that's like, he's just getting up in the run a bit. These are... All right. So what I've done there is I've expanded it from being like 1 minute to these like 10-minute gaps, because this guy ran so long here. Like a 10-minute gap has got a lot of information there, right? So that's what happens when you do stuff like that. That's why I kept it like 1 minute. It was a little simpler to do. Let me try a different one real quick. I think this one here was kind of cool. Oh no, I'm sorry. I actually wanted to do the one that is in San Bernardino, which this reverse one I think is what it was. Might have been what I had before, but it's going to change a little bit. Okay, so if you play it long enough, you'll start noticing as the runner gets further up the hill, some of the tunes change quite a bit, which is pretty interesting. And if you don't hear it yet, you might be able to guess what the next step to this might be. I need to undo what I did here. Undo those things because I'm going to change again. Step 4. So still doing everything here. I'm going to have the distortion, reverb, and all that in here. But now, because it only made sense. Right? I mean, it only made sense after that point, right? So this is actually kind of cool because it does highlight it when you look at visually the way the colors change and the size of things change and whatnot. And I could exaggerate things a bit more, but then it kind of gets a little ridiculous. You can't really tell what's happening much. Even this way, because Pac-Man's covering everything. Tough to tell. But like at this point here, the heart rate was a little lower. Oh, sorry, the cadence was lower. It started to slow down. So he's probably going up the trail a bit more here. You can see the different elevations and stuff. So that's really cool. With all that to say is that this is all completely experimental, because again, it's just kind of stuff that we've been investigating for quite a while, actually. Like I said, talking to our accessibility group and stuff like that, we're curious how useful something like this could be. Obviously not with techno beats, stuff like that, but maybe in some other ways that we can kind of have some auditory signals when you're looking at data on a map in one way or another. Again, it's a fun way to explore the data, especially when you start looking, like I said, earthquake data, weather data, all different sorts of data sets that are out there you can do. It's just really cool to kind of play around with and do stuff with. It's kind of been the kind of side stuff I've been working on for quite a while now. So again, you can find me on socials and stuff. If you're interested in other people that talk about mapping stuff, people have been in this industry a long time. I have a podcast called The Bounding Box. Like I said, I work at Esri, and we are always hiring. We've never not hired every year I've been there, which is like 10 years now. So if you're interested, please feel free to hit us up. Thank you.